Hey guys, it's Miss Batty here, back with Lesson 6 on our Populations and Resources series. I hope that you've been starting to feel like you're figuring out about some things that could be going on with the moon jelly populations. We've collected a lot of evidence so far, and I'm really excited to start hearing your thinking in today's lesson. What you're going to need for the lesson today is a pencil or pen, some lined or blanked paper. Now, if you have the packet pages that go with this lesson, you may also want to get those out right now. Something that's optional, but that I encourage you, if you have the ability to do so, would be to get logged on to Amplify and open up the Populations and Resources digital model. You need to pause the video for a moment to make sure that you can get there. Go ahead. If you don't have access, no worries, we are going to do this together. As I mentioned before, we have collected a lot of evidence and figured out some really key ideas about how populations change or stay the same over time. We know that within a population, organisms are always born and always dying. This means that even when a population is staying the same, something is being added or taken away. It is just balanced. A system can be stable even as things are being added to or removed from it. If the amounts being added and removed are not equal, then the system will change. We saw this with our Populations and Resources game and with our video with the tanks of water. If the number of births and deaths in a given time are equal, then the population size will be stable. If there are more births and deaths in a given time, then the size of the population will increase. If there are fewer births and deaths, then the size of the population will decrease. We learned very quickly that the key to population growth or stability is in the ratio of births and deaths. We must look at both sides to understand and make predictions about what is happening in a population. Because of this, we really started diving in to what might be affecting either sides of the ratio. And we figured out that organisms in a population need to release energy from energy storage molecules in order to reproduce, or in other words, give birth. Organisms in these consumer populations get their energy storage molecules from eating something called resource populations. Now we know that some organisms can make their own energy, but most need to eat to get these energy storage molecules. The more energy storage molecules available to a population, the more the organisms in that population can reproduce. We saw this with the yeast, with the crickets, and also with the organisms in the digital model. Today, we are going to start shifting to think about the other side of the ratio, our death rates. We know that the moon jelly population is increasing. This means that the number of births is outweighing the number of deaths. Now our question is, why is this occurring? We've looked at how the number of births might be able to increase. What if it's that the number of deaths are just decreasing? Today, we are going to collect evidence for why and how the number of deaths might change in a population. This was an idea that some of us had from the very beginning. Let's start by thinking about what we're going to be doing today. In our last lesson, you watched me investigate how the number of births might be changed by planning and carrying out an investigation in the digital model. Today, it is your turn. You will plan and conduct an investigation in the digital model to figure out what can affect the number of deaths in a population. Again, we are going to use the 3 populations ecosystem in the middle of the digital model options. If you need to pause the video for a moment and get to the digital model, then go ahead and do so. If not, keep following along with me. What you're going to do today is focus your investigations on our wee bug population. As we're focusing on the wee bugs, I want you to pause the video for a moment and find a person to check in with, or maybe a friend that you can text or message with. And I want you to ask yourself, what is the consumer and the resource populations for the wee bugs? Let's think about that for a moment. Okay, so as we have our food web here, we can see that the energy storage molecules are being transferred this way across our food web, meaning that the green leaves are the resource population for the wee bugs, and the furbles are the consumer population of the wee bugs. The furbles eat the wee bugs, and the wee bugs eat the green leaves. So, you today are going to have to think about what changes are going to decrease the number of deaths in the wee bug population. We know that in the moon jellies, for the balance of births and deaths to become unbalanced, either the births had to increase or the deaths had to decrease, or maybe both. So we really want to understand what could cause deaths to decrease. I want you to pause the video again, and I want you to discuss with somebody around the house, or maybe somebody you can message, what is your prediction or your initial idea for what change might affect and decrease the number of deaths in the wee bug population. Good luck! Okay, so now you're going to start planning your investigation. As we mentioned last time, you are going to have to pick what your manipulated variable is. You may also have heard of this as being called the independent variable. Now remember, this is the thing that you are going to change. It is the thing that you suspect is going to affect the number of deaths in the wee bug population. Which one did you pick? That is your manipulated variable. Our responding, or our dependent variable, is going to be the number of wee bug deaths. Now obviously this is the thing that we are trying to look for and understand. So this is the thing we are going to measure. Our controlled variables are going to be things that we keep the same. If you need a reminder, I encourage you to go back into lesson 5 to take a look at some of the things that we kept controlled in our test for the number of birth changes. What things do you not want to mess with? We only want to have one manipulated variable or change that you're making, so that we really can be sure that this is the thing that is affecting the number of wee bug deaths. If you have access to a digital model, now would be the time to pause the video, plan your investigation, and then carry it out. Make sure to take data and record information about the deaths before and after your change. Figure out whether or not your manipulated variable does cause a change in the deaths of the wee bug populations. Good luck! If not, follow along with me and we are going to plan an investigation together. So, I decided that for my manipulated variable, I wanted to change the number of furbles. Now, we all have the same responding variable here. We're all trying to figure out how we can affect the number of deaths in the wee bugs. So that's going to be the same. For my controlled variables, I am not going to mess with the green leaves at all. I'm going to keep those the same before and after. I also am going to make sure that I give the same amount of time before and after I make my change, so that I can really compare how many deaths occur in an exact amount of time. I'm going to leave about 25 time units for before and after. Now, what kind of change should we do to the furbles? Should we increase them or decrease? Let's see. I think that we should try to decrease the number of furbles. I'm thinking that the furbles are eating the wee bugs, and so maybe if there are less of them, then they might not be able to eat as many. but it might just mean that because there are less verbals, they're eating more because there are more available. So let's take a look and see what is going on. Okay, so here I am in the digital model, in the populations and resources digital model, and I am in the 3 populations ecosystem. I just am worried about my furballs, my weebugs, my greenleafs, and as you'll see, I haven't messed with anything yet. It's only been 2 time frames. I am going to leave things alone so that we can kind of get a baseline understanding of how the ecosystem works. And like I said, I want to make sure that I'm doing kind of the same time chunk before and after. So I just picked 25 as my number, and I'm going to pause it right on 25. And then now things get interesting. So we said that our manipulated variable was going to be affecting the number of furballs in the ecosystem. And our specific change that we are going to make is to decrease the furballs in the ecosystem. And I'm almost going to get rid of them all, actually. We'll leave 5 left to see how they can make up for their other organisms that are missing. And I'm gonna lock in the number of furballs. I'm going to leave the green leaves alone, as we said. I'm going to leave oxygen alone. Just make sure that there's nothing else being changed, because I really want to understand whether the furballs are affecting things in the weebug populations. All right, let's go ahead and hit that play. Wow, we don't really see any furballs now. Those 5 look like they're still staying alive, but oh, one just disappeared. Okay, I'm gonna pause there. So that's 50. I let it go for 25 time frames again. So we are going to take a look at the moment at what has happened to the weebugs. Remember, our focus question is, can we affect the number of deaths that are happening? So if we go ahead and take a look in the digital model, we're starting with about 110 weebugs. And over this first little time chunk, that 25 time frames, notice how pretty straight that line is, right? Telling us that the weebug population is pretty stable during this time. It looks like 32 weebugs did die in this time frame, but also 34 were born. So that population ratio of births to death is pretty balanced. Now this is the moment where I made my change, and so we are going to take a look at what starts to happen. Now I can see right away that our light blue line is really going up. It is increasing, meaning that our births are really outweighing our deaths. So I want to go ahead and think about for a moment what we are seeing here. It looks like in this second time frame, actually only 20 of the weebugs died. 98 were born though. So this is really showing us that this change had a large effect. I mean, if we go right back to this marker, we can see visually a huge change in the pattern of what is happening. And if we look at the number of deaths that were occurring here, around 33 to 35, versus only the 20 that are occurring in this time frame, it is really clear to me that this change in the furball population is having an effect on the amount of deaths that are occurring in the weebugs. Okay, I'm so glad we got to collect some evidence there, and I really am interested to hear from my students, and I'm sure your teachers are interested to hear from you about your investigations. There were many different things that you could have chosen to manipulate in the digital model. You could have increased the green leaves, decreased the green leaves, increased or decreased the furballs. Now, I chose, as you might know if you stayed along with my investigation, to decrease the number of furballs. And we really saw that this seemed to have an effect on the number of wee bug deaths. We saw that the wee bug deaths decreased. So what I would like you to do is pause your video for a moment. Find that person in your house or get on your chat or your text and find that friend and figure out why you think this is happening. We saw that by changing the furballs and decreasing, how many are in the digital model, we affect the number of deaths that the wee bugs are having. Why is this occurring? Using what we understand about how these organisms interact, why might decreasing the furballs have any effect on the number of deaths occurring in the wee bugs? Yes, you guys got it. The larger the consumer population, which was our furballs in this case, the more energy storage molecules it needs. Therefore, it will eat more, causing more deaths in the resource population. We saw the opposite happen. The smaller the consumer population, the less energy storage molecules it will need. Therefore, overall, that population will eat less and there will be less deaths in the resource population. So, there we have it. One way that we can affect the deaths that are occurring in a population is by manipulating the thing that eats it, or the consumer population. I wonder if any of your tests also showed that we can affect the number of deaths in a population. I'm really excited to hear some feedback that we can talk about in our next lesson. We have collected a lot of evidence so far, and we're not done yet. But we can maybe answer some more questions about our moon jelly populations. How can we apply all of this understanding about births and deaths and things that affect them to what could possibly be going on with our moon jellies? What information do we need about the populations in the ecosystem where the moon jellies live to help us understand what could be going on? Here is the Glacier Sea food web. I want you to pause the video for a moment and again, find somebody to check in with. What is this food web telling you about the moon jelly and the things that it is interacting with? What is the moon jelly population eating? What is it being eaten by? How does that help us to know what kind of data we might need to be looking for? Make sure you pause and go ahead and think about this before moving on. Okay, so I'm sure many of you have figured out, and maybe you had to go back and look at our article or look back at another video to figure out how to read that food web. That's totally okay. I want you to be doing those kinds of things to review and make sure you're understanding how this works. But I think we all can see right here our moon jelly population. Here is the thing that we are trying to understand more about. We know that we need to look more into the births and deaths that these moon jellies are having. And something that might help us do that is by understanding what is going on in the population that eats the moon jelly and also the population that the moon jelly eats. Now, from this food web, we can see that the moon jelly is receiving energy storage molecules from this population called the zooplankton. This is the moon jelly's resource population, and we know that this has an effect on the number of births that the moon jelly population can have. We also know that the moon jellies are giving energy storage molecules to the sea turtles. This is their consumer population. And as we just realized, this might be having an effect on the number of deaths that are occurring in the moon jelly populations. It's going to be really helpful for us to take a moment to see if we have any data or evidence about these populations. We already know that the moon jellies were stable and then began to increase in about 2000. Now it's time to think about what might be occurring that caused this to start. I want you to pause the video for a moment and find somebody to check in with. What is your prediction about the data that we are about to look at? Many of you had ideas at the beginning about what might be affecting the moon jelly populations. Is your idea still the same? Has it changed? What are you thinking? Before we take a look at the evidence, I want you to make a prediction about what we might see in the populations of zooplankton and sea turtles in the Glacier Sea ecosystem. All right, now it's time to take a look at some evidence and put all our understanding and learning to work here. We have 3 pieces of evidence about the zooplankton populations and the sea turtle populations. If you would like, I would encourage you to pause the video on each evidence card. Jot down some information or annotations about what you're seeing. Does it seem like a reliable piece of evidence? Remember that our evidence criterion for population sampling is that the samples represent as much of the whole as possible. Also, look for information about what is happening to the populations based on the evidence. It might help to sketch out a graph, just like we have been doing for the moon jellies, to give you a visual of what is occurring to these populations over time. I'm so excited that you now are going to put all your learning to the test by looking at these different evidence pieces. This is the work of scientists. I'll check back in with you in a couple of minutes after you've had some time to look at the evidence. Don't forget to pause the video on each evidence card to think for yourself before we check back in. Good luck! All right, so I hope you had some time to look through the evidence and make your own thoughts and annotations. I'm going to share with you a little bit about what I noticed. In the evidence card A, the first thing that I noticed was it seems like the sample sites are spread out in the Glacier Sea. I see some close to shore, some out in the more middle of the sea, and there are 6 different locations. The other thing that I thought was really important was that it seems that the population was stable and also began to increase around 2000, just like our moon jelly populations. I sketched a graph to think about what this might look like. And to me, this reminded me very much of the moon jelly graphs that we have seen in previous lessons. In evidence card B, something that I noticed right away was that all the samples were taken by the shore. One thing that immediately came to mind was, what about the rest of the sea? This does not seem as strong as evidence card A. I feel that these samples really don't give us a picture of the whole Glacier Sea, and that is something we're looking for. I did notice that even though this may not be the strongest of evidence, it is backing up evidence card A that the population was stable and then increasing around 2000, just like the moon jelly populations. In evidence card C, I noticed that there were less samples, so it is not quite as reliable as the zooplankton evidence, but I am happy to see that there is a population sample by the shore and also some further out. I saw that in this case, again, there was a change happening around 2000, but this time the population was starting to decrease. sketched a graph to think about this. And I'm noticing this is looking similar to my other graphs, but with the exception of a decrease happening in 2000. It seems like a lot of changes were happening around 2000 in the Glacier Sea. And what does this all mean? What could have caused the size of the moon jelly population to increase? We now have seen some evidence for what was occurring to the zooplankton and the sea turtles during this time. How does this help us? How does this information relate to the number of births and deaths in the moon jellies, and why do we care? I want you to pause the video for a moment. If you need to go back and look at the evidence one more time. And then I want you to write or draw whatever it works for you. You could find somebody to check in with, call that friend, find that family member, or somebody around the house to check in with. And I want you to reflect on what your thinking is right now. You might have the same thinking as you did at the beginning, and that's totally okay, as long as it is backed up by the evidence. You might have changed your thinking, which is totally okay as well. You might have kind of changed your thinking, or maybe have part that's the same and something that you're wanting to add on. Whatever your thinking is, I hope that you are using the evidence to guide that. Do you think that this increase was occurring because the number of births was increasing? Or perhaps that the number of deaths was decreasing? Or is both of these things happening at the same time? What is the evidence telling you? What does our learning help us understand about the zooplankton and sea turtle evidence? Make sure you pause the video and take this time to reflect. I'm really excited to hear from my own students about their thinking now that we've got to see more evidence, and I'm sure your teachers are too. So, just as before, we maybe have answered some questions, but there is still so much left for us to understand. I notice in the ecosystem, there are so many more organisms than just the zooplankton and the sea turtles. Are these having any effect? To learn more about the other populations of organisms in the ecosystem, I encourage you to check out the Arctic Ecosystem article if you haven't already. You can listen to me reading it in the voice recording, or if you have access to the article, you could read and annotate it yourself. Next time, we'll come back after having some time to think about what we think is occurring, and we'll start to investigate if there's any more to the story than what we understand so far. You guys have done such great work, and I'm so excited to see you using evidence and critical thinking to help us understand what is happening to the moon jellies. See you next time.